Yeah, I think that kind of did it. Let me see if this works. I think I actually made a flaw by making the stream for kids. And that was not really the point of it all. So yes, we're live now, and I think that kind of settled it. We are actually going to talk about the application layer right now, and okay. And the application layer itself is actually very important to understand whenever you're going to go ahead and help yourself in the terms of hacking and getting that universe open for you. Now, of course, we're talking about all of this in terms of education. So talking about the application at the very first layer, we talk about the OSI model, as I have representation of right here, actually, just one of the 100,000 different features you can find online. And basically, it's going to tell you all about the different kind of layers there are, the OSI layer. Now, one thing I want to give like for the intro of this is that many teachers these days in educations, they just don't focus on teaching the application layer or the OSI model well enough. So it's a bit difficult for many students that I know to get started with this because it didn't really was a part of the education, wasn't incorporated a part of the knowledge part. And I actually think that is a flaw. Just because it's old knowledge doesn't mean that it's outdated because it's still there in the computer. The computer still works the same way as it did since 1960, something like that. It's just more advanced now with more programs and a lot more graphics, but doesn't change the fact that beneath all of that, what you look at is at the application layers where you primarily work is on applications, you're clicking buttons and so on. It really just means that, what actually goes under the hood, most people doesn't really know about that. So in this presentation, I'm gonna basically talk about, it's called network theory, but it's more like about the application layer itself, and not really gonna touch upon the other layers. That's gonna be another day, another live stream. So basically, on the application layer, we have all the tools, the programs you run, but also some protocols called application layer protocols. And this is where we are going to talk about, what is an actual application layer protocol and what is it, why it's important to us. Now, we use browsers all day long, internet browsers like Safari and Chrome, all the good stuff. And whenever we run those programs, we are interacting with another web server, and that web server is actually communicating with our browser through the application layer. Now, before we get to the application layer, you probably guessed it. We're going to go through the physical, the data network, the transport, the session, the presentation layer. All of those are being run through in a certain way. Now, I'm gonna break that out right now. There is not like a layer inside a computer, right? So you're not gonna see a layer, okay? That's not the case here. What you will see is a way of code interacting with traffic. So there is an actual input port down the network part on your computer, a physical wire or Wi-Fi connection. That's the same in this particular case. Now, this is where the physical layer will get the actual data, and this is where it's going to be translated upwards and dissected in different ways through the different layers. So you can imagine a layer like, some if statements or something like that in the code, or different kind of objects that, interact with the packages, which is of course in binary be converted to hexadecimal in most occasions. And that's really just the case, that's how it works. And that's kind of, when you get it, you will be like, oh, is it just? Yeah, because even so, if it's just right, it's still so advanced that when you're gonna look at it with your own eyes, you're gonna be like, whoa. But one day when you open a program, let's call Wireshark, for example, when you interact with real traffic, intercepted through your network interface cards, you will see the actual traffic in Wireshark looking just like, whenever you receive it. And then you will notice the idea behind all the network theory you learn, and you understand the whole fact behind it, that it's not really that advanced. It just takes a bit of demystifying. I will usually call it that. I demystify things for my students when I teach in my classes. Obviously, I have a big whiteboard, and I can walk around and talk and wave with my arms and stuff like that. But, just in all casual, ways of saying network traffic, it's not that difficult. It's just very important whenever you're going to begin with cybersecurity, you understand some things about it. And there are many different kind of protocols and programs that actually have what we're going to call an application layer protocol, like browsers, Skype, which is, not working anymore, Zoom, Teams for meetings, any program that can interact with something online does have an application layer protocol. That is just the way it is. There's no way around it. It's just the way it's being made. So today we will dive in a bit on the HTTP protocol, and I think we're also going to touch upon DNS and something like that. But, this is a presentation that I usually use for my students whenever we're going to talk about the application layer. And now I'm going to make myself a little less in size, so it's easier for you to see the actual screen here down below. So we have right here the application layer, right? So the application layer is where we are looking at stuff like FTP, SMTP, HTTP, DNS, Telnet, and many more different kind of protocols you can go ahead and use. And well, most of you guys probably going to use the HTTP protocol every day without even thinking about it, okay? Many of you guys probably never heard about Telnet because it's like an old protocol that's not really used anymore. And it's like, yeah, you just use SSH these days because it's a lot more secure. And that is true. But still, we need to understand the all basics of stuff, and using stuff like FTP, the file transfer protocol, are still something we do, but many people these days are more interacting with stuff like drag and drop or some service online that, can, like cloud sharing, or we share files, or we share, or whatever they call all of them, right? So basically, some of the protocols are very important, I would say, for cybersecurity. Understanding how HTTP works, understanding how, FTP works is probably very important. Also, DNS is very important to understand, of the mention right here. Now, the first thing is like, what is a protocol? Because we are still talking about like, what is a protocol all day long. So many people actually do not understand this, because they're like, what is a protocol? Like, so we think about a protocol as something we do, something that is highly interactive, but also highly agreeable. And at the same time, also something that is the same every time we do it. That's very static. You can say like, yeah, so if I say like, hey, you say hi, okay? And if I say got the time, you're gonna give me the time, right? So that's like the human way of having a protocol going on. So this is like saying, if you go and interact with, some dude at the bar, and you say, hey, what's up? Okay. So most likely the answer is just going to be, hey, what's up? Okay. So that's going to be the same thing, the same question. And that is actually a social protocol, but social protocols are very different and can change from time to time. But in a computer, they cannot, because computers cannot think, and they cannot, they're not sentient, and they are not changing their behavior. They're doing what they're told to do. So if you have a TCP connection, which is using something called the TCP protocol, which is actually located on another layer, whenever you're gonna, open up a connection request to another service, you will basically say like, hey, I'm right here, I'm gonna connect to you, and then it's gonna reply back with the connection reply, and then you can go ahead and download some stuff. If this is, for example, a web server, and then you're getting the file back from the GET request. That is really how it works in like it all very, very down to earth, explorative, explanation wise way. Nothing crazy going on right here. So, yeah. Okay. So, of course, we can go a lot more detail. I could do that, but I'm not really going to do that this particular video because this is just an intro to it. So I would say you need to understand, a bit of this and that, and you should definitely go ahead and research further. Go ahead and search how TCP works, how UDP work, how HTTP work, and so on, and read, more detailed texts about that. That is the way to go. All right. So the three-way handshake, whenever you are, connecting yourself to a service, you need to make sure that the connection is established. This is also what you're going to call as a full open connection. So basically, whenever you look at your server logs or whatever like that, you will basically see that, you created this, full open connection using the TCP protocol, and that's very normal, it's very common. This is the way it should be. So this is exactly how things are used. But what you could probably think right now is if I send, think about this, I'm user A and server B is the one I want to communicate with. So the communication stack is that I sent a synchronization flag. Now, don't think too much about this right now, but I sent a SYN package, like a synchronization package. So that package is going to end up on the server side and say like, okay, I'm going to synchronize and acknowledge the second line here at the top, right? So basically I'm saying, I want to synchronize, server says synchronize, acknowledge, is saying like, yeah, I want to do that. Then I sent back, okay, that's fine, acknowledge, and then connection is established. What if now I send a SYN package to the server, I get a SYN ACK back, and I do stuff from right there. I don't do anything. I don't send the ACK package back. The third step is missing. No connection is going to be established. What is this actually? Why is this a thing? And it is a thing. This is actually something called port scanning. Okay, that is one way a SYN ACK port scanning. So you're gonna send a synchronization package saying, "Hey, I want to connect." If you get a reply back, the port is open. Ta-da! That easy it is, right? That is how stuff like Nmap and all the different kind of port scanner programs work. They utilize a different way of creating a three-way handshake. You could also just send an ACK package and see what happens. The server will respond in some way, probably, and that's also going to tell you that the port. So, but it's going to get into a bit of an advance right now. I'm just going to tell you right now that there are things behind how protocols work that are going to be misused or used in different kind of programs in order to verify if a port is open. However, in this video, I know I drop a bit of, extra knowledge parts here and there, but we're talking about the application there. There was just an extra part. So let's continue. So we have an HTTP protocol, right? And this is just a protocol used to request resources from web servers. So you're sending mostly GET requests to the web server, which is getting the data back from the web server to your browser. You're downloading it from web server. Whenever you're gonna send something to this web server, like you're logging in or creating something, you usually use something called a post request, and that post request is gonna make sure that the data is sent correctly to the server. All right, so the HTTP protocols actually support other request types, and we're talking about post, get, update, put, delete options. And of course, in most cases, we only use like post and get, and that's really just the way it is. All right, so you can say like this, how HTTP works. You have an application, and from the application here, you go through different kinds of TCP and IP layer and network. You go to the internet, and it's going to be intercepted from the bottom on the other machine and transfers it upwards to the application there. So it's like kind of like and like that, exactly like that. Now I know it's a bit, like, can I see this? No, you cannot. You cannot see it physically in the computer. It's all code running in the background. It's just an orchestral setup of how the code is interacting with the traffic you're getting. Of course, there's some hardware, there, but in all honesty, it's just, a way of, how things are connected. So I cannot show it, and I can only tell you about it, which is why it's called network theory. This is an actual HTTP request. It's a GET request for some particular website, and the host is .net cs.umass.edo. The GET request is interested in downloading the file called index.html. Pay attention to the HTTP. It's set 1.1. Okay, so you are probably thinking right now, what about the HTTPS thing? Well, there is no HTTPS mentioned right here, and because it's a part of the browser interaction where the things are encoded, sorry, not encoded, encrypted, and React. So when you set the request, you're going to get a response. It's going to look something like this. And basically down below, this is like a lot of data. And that data below will then be the data you will see in the web page. So your browser will intercept all this and dissect it. And basically, all the words data is going to be your HTML, your CSS, and your JavaScript and such will be intercepted if they are in files, individually in files. They'll be sent to you individually in different response messages. If it's inline in the actual, as a part of the HTML, that in script tags inside HTML code, it's going to be sent there. So, which is why whenever we're going to use some programs called Burp, Proxy, for example, to intercept HTTP requests and so on, you will see a little of this and that, and basically, yeah, it's going to be a bit more difficult to explain Burp, in this video, so I'm not going to do that. But, another video, I'm definitely going to go ahead and dive into Burp because it's a very beautiful program. It takes a while to get used to it, but it's also very, very interesting for web penetration testing. Anyways, this is a response, so that is what you get back from the server whenever you send the actual request, which is the first one right there. All right, so whenever you look at something called status code, but you do look at those occasionally when you do, for example, let's say you run a program called GoBuster or DearBuster or Derp, which are 3 different programs that do the same thing. They scan websites for files and folders that are interesting for us to visit as a penetration tester. And when you get this 200 OK back from them, it basically means that it's a successful request. The resource exists, the file exists, and this is basically what it means. 301 move permanently could be 1, but the 404 and 455 is something that we're going to pay attention to when we're going to do our scanning of the web server. Now, I talked about, we're also going to briefly talk about the DNS, and even so, this is going to be a very short live stream. I'm going to touch upon it, and DNS is the equivalent of a phone book. Okay, so it's whenever you go to the internet, you are basically saying, I want to visit like example.com, but the internet doesn't work in letters; it works in numbers called IP addresses. So it needs an IP. But you don't have the IP, but you do have the address, and that is the example.com. Okay, so think about it this way. Imagine that that you live on a street called street names Riverdale 123, and when I say like, yeah, I understand that, but I need the unique number identification of that address. Then you're going to look it up and you're going to get some weird number. That's the number I'm talking about. It's called the IP address. Okay, so of course you use port 53. It's a UDP protocol. And it is used by HTTP protocol a lot whenever you're going to look up the IP address of a particular website. Of course, also something called caching, and whenever you cache something, it will be stored in either your computer or the ISPs, your internet service provider, or another, cache somewhere in your hardware at home if you have something around, you know. Anyways, DNS works like that. I'm going to go ahead and type in the address, follow the numbers here, right? So I'm going to type in the numbers of whatever www.exam.dk. And this, the initial takes us to the DK zone because this is where the address DNS server of the .dk domains exists. And then it's going to take us onwards to the computer where it's going to take us to the location of the exam.dk and then arrive at the address and say like, okay, so then we're there. I know it seems like a bit simplified. It is. In reality, DNS works something like this, but there are some steps behind where you communicate with different kind of servers in order to get to a destination point. Also something called DNS Secure. I'm going to briefly skip that for now because it's going to become a bit too advanced. And the bit more advanced view on DNS is like this. You have a requesting host. You have a local DNS server, which is most occasions at your ISP. And then there are something called root DNS, top-level DNS, and authoritative DNS servers. And these are different kind of servers you communicate with whenever you are interested in getting to your actual IP address of the address you are requesting. So I'm gonna leave it here for now because I just wanted to do like a quick video and get it started for you how all this works. I know the slideshow is a bit longer, but it's not really something that we're going to touch upon a lot right now because it's going to become a bit too advanced. What I really want to say is that, and I'm going to make myself a bit bigger now, like boom, I'm big now. Okay, so is that I'm going to do more live streams, and I will definitely do more live streams about this topic, about network theory, but I want to see how it works and so on. But I also want to do some fun interactive live streams. Maybe gonna migrate to Twitch at some point, but for now, I'm gonna stay on YouTube and do more live streams. So I want to say thank you for listening and following this small, short introduction live stream to application layer. Hope to see you again online.